Hello everyone. So I'm shooting this, recording this part maybe the third or fourth time because I have been consistently facing some technical errors while recording. Sometimes no audio, sometimes some error while recording. So that's why the delay in posting this video. But finally, I think this part I've figured out certain technical glitches, and I think this part should work absolutely fine. Okay, let's start with circular functions of more angles. Now we have been finding the values of trigonometric ratios of certain standard angles from 0 degree till 360 degrees, and we have made a table for that, but there are certain more angles which are included in this list. So these angles are 18 degrees, 36 degrees, 54 degrees and 72 degrees. So you can find the trigonometric ratios of these angles as well, all the trigonometric ratios. And this part is about finding the trigonometric ratios of these angles. Okay, so let's first go to the derivations. Let's understand everything. First we'll find the value of sine 18 degrees. Okay, sine 18 degrees. Now please understand that you will see a lot of scribbling and highlighting in this part. So I'm just going to move my you can say pointer or cursor around on the highlighted part, and I will explain you. So I won't write anything because it's already written couple of times. Okay, so let A, we have to find sine 18. Okay, so let A be 18 degrees. So what will be 5A? 5A will be 90 degrees. So can we write 5A as 2A plus 3A? Yes. So 2A plus 3A will be 90 degree. So we took A as 18 degrees and we found 5A to be 90 degrees. We wrote 5A as 2A plus 3A, which is 90. Now we'll take 3A to the other side. So 2A becomes 90 minus 3A. Now we take sine of both the sides. So sine 2A is equal to sine of 90 minus 3A. Sine 90 minus theta is cos theta. So sine 90 minus 3A will be cos 3A. So sine 2A will be equal to cos 3A. Now sine 2A is nothing but 2 sine A cos A, the identity. Sine 2 theta's identity. So 4 and cos 3A is equal to 4 cos cube A minus 3 cos A. That's the identity of cos 3A. We put the values here. Now we divide the whole both the sides of the equation by cos A, because we want to find the value of sine 18. So we don't need cos. So it will become 2 sine A, cos A will be divided, is equal to 4 cos square A minus 3. So 2 sine A is equal to, in the place of cos square A, we have 1 minus sine square A. So 2 sine A is equal to 4 bracket 1 minus sine square A minus 3. So 2 sine A is equal to 4 minus 4 sine square A minus 3. So what do we do is we take all the terms to the other side and we get 4 sine square A plus 2 sine A minus 1 is equal to 0. 4 minus 3 is 1, which goes to the other side, becomes minus 1. Now this is nothing but a quadratic equation where x or your variable is sine A. So we use quadratic formula to solve this quadratic equation and we get minus 2 plus minus under root of 4 plus 16 by 8. On simplifying, we get minus 2 plus minus 2 root 5 by 8, or minus 1 plus minus root 5 by 4. Now since A is nothing but 18 degrees, which lies in the first quadrant, the value of sine A will always be positive. So we neglect or reject the negative sign. So our value of sine 18 will be minus 1 plus root 5 by 4, or in a better way, root 5 minus 1 by 4. So sine 18 degrees is root 5 minus 1 by 4. Moving on, we have to find the value of cos 18. So cos square 18 plus sine square 18 is equal to 1. Cos square theta plus sine square theta is 1. So cos square 18 is equal to 1 minus sine square 18. So cos square 18 is equal to 1 minus, in the bracket, root 5 minus 1 by 4 the whole square. Okay, we just put the value of sine 18 and square it. Now we open the bracket, we take LCM, simplify, we get the value of cos square 18 as 10 plus 2 root 5 by 16. Now we want to find cos 18, so we take square root of both the sides. So here we get plus minus under root of 10 plus 2 root 5 by 4. 16 becomes 4, and this 10 plus 2 root 5 is under root because we have taken square root. But 18 degrees lies in the first quadrant, hence cos 18 will be positive. So cos 18 will be plus under root of 10 plus 2 root 5 by 4, which is the value of cos 18. Moving on. Okay, the next is we have to find the value of sine 72 and cos 72. Very easy. See, 72 is a complementary angle of 18. So sine 72 is sine of 90 minus 18, which is sine 90 minus theta, which is cos theta or cos 18. And we just found the value of cos 18. So sine 72 is equal to cos 18. Similarly, cos 72 is equal to sine 18 with the help of complementary relation, which also we found in the previous part, root 5 minus 1 by 4. So sine 72 and cos 72 are ready for you. Cosec 18. Cosec 18. Cosec 18 is reciprocal of sine 18. We know the value of sine 18, 4 by root 5 minus 1. Now we just rationalize the denominator. When we rationalize the denominator, we get the value of cosec 18, root 5 plus 1. Very simple. Cos 36. This is interesting. So we take angle A as 36. We have to find cos 36. So 5A is equal to 180 degree. So we can write 5A as 2A plus 3A is equal to 180. We take 2A is equal to 180 minus 3A and sine on both the sides. Sine of 2A is equal to sine of 180 minus 3A. Now sine 2A is 2 sine A cos A. And sine 180 minus 3A is sine 3A, because 180 minus 3A lies in the second quadrant. In second quadrant, sine is positive. So sine 2A is equal to sine 3A. Now what is the formula for sine 3A? 3 sine A minus 4 sine cube A. So we divide both the side by sine, so that we get 2 cos A is equal to 3 minus 4 sine square A. In the place of sine square A, we put 1 minus cos square A. Again, we get a quadratic equation just like the first derivation we did. 4 cos square A minus 2 cos A minus 1 is equal to 0. This is a quadratic equation in cos A. In the place of cos A, you can put x also to understand. So we solve this quadratic equation with the help of quadratic formula, which will give us 2 plus minus under root of 4 plus 16 by 8, which is 2 plus 2 root 5 by 8, which is 1 plus minus root 5 by 4. We reject the minus sign because 36 degree lies in the first quadrant. In first quadrant, cos is positive. So cos 36 is 1 plus root 5 by 4 or root 5 plus 1 by 4. That's the value of cos 36. Now to find sin 36 should not be a bigger deal. Sin 36 can be found very easily. Since cos 36 is equal to sin 36, cos square 36 plus sin square 36 is 1. Sin square 36 is 1 minus cos square 36. We already know the value of cos square 36. We just put the value of cos 36 here and square it, simplify it, take LCM, and we find the value of sin 36 by taking square root on both the side, which is plus minus under root of 10 minus 2 root 5 by 4. But since 36 lies in the first quadrant, sign of any angle in the first quadrant is always positive, so we reject the negative sign and we get sin 36 as root of 10 minus 2 root 5 by 4. So sin 36 is under root of 10 minus 2 root 5 by 4. Then sin 54 and cos 54. 54 degree is a complement of 36 degrees. So sin 54 is equal to sin of 90 minus 36, which is cos 36. Sin 54 is equal to cos 36, which we just found in the previous part. root 5 plus 1 by 4. And cos 54 is equal to sin 36, which is root of 10 minus 2 root 5 by 4, which we just found in the previous part. So sin 54 and cos 54 is also not big deal. Sec 36 is reciprocal of cos 36. So we take reciprocal of cos 36, rationalize the denominator, and here we go. Sec 36 is root 5 minus 1. So the very common question I get is, do we have to remember these values or we can derive? See, if you remember these values, it will be very easy for all of you to solve questions based on these values. If you don't remember all the values, then also it's not a problem. You can derive few of the values, but it is better to remember the values of sine 18 and cos 18 degrees. Let's discuss some numericals. Okay, the first one is you have to prove that sine square 72 minus sine square 60 is equal to root 5 minus 1 by 8. So you have two options here. Either you can directly substitute the value of sine 72 and sine 60 in this equation and solve it and get the answer. If not, then you can do one more thing. You can convert this sine 72, sine square 72 or sine 72 the whole square in terms of sine 18 or cos 18 if you can, and then put its value and solve it. So here what I have done is I have first written sine square 72 as 1 minus cos square 72. I have left sine square 60 as it is because I know the value of sine 60 root 3 by 2 and sine square 60 is root 3 by 2 the whole square. Cos square 72 I have written as cos of 90 minus 18 the whole square, because 90 minus 18 is 72. Cos 90 minus 18 is sine 18. So we have 1 minus sine 18 the whole square, or 1 minus sine square 18. Root 3 by 2 the whole square becomes 3 by 4. So 1 minus sine square 18 minus 3 by 4. I know the value of sine square 18, which is root 5 minus 1 by 4 the whole square minus 3 by 4. So this is the whole equation which I have to, expression which I have to solve and simplify and get the value equal to root 5 minus 1 by 8. Or I can simply put the value of sine 72 here, square it, minus root 3 by 2 the whole square, simplify and get the answer. So there are two options. You can pause the video, try both of them or one of them, and then, you know, in similar kind of questions, you can what you can do is you can remember or memorize the value of whichever. If you can memorize all the values, very nice. If you cannot, then memorize at least sine 18 and cos 18, which will be useful in these kind of situations. Please pause the video and solve it further. Okay, I hope you're done with this. Let's go ahead and check out what we have here. The next question we have to prove that sine pi by 5 multiplied by sine 2 pi by 5, sine 3 pi by 5, sine 4 pi by 5 is equal to 5 by 16, or sine 36, sine 72, sine 108, sine 144 is equal to 5 by 16. One and the same thing. Pi by 5 is 36, 2 pi by 5 is 72, 3 pi by 5 is 108 and 4 pi by 5 is 144. So what I've done over here is I've written sine 108 as 90 plus 18, sine 144 as 180 minus 36. So sine 90 plus 18 is cos 18, right? Sine 180 minus 36 is sine 36. So we have sine 72 and cos 18. They both are nothing but cos 18, right? So sine 36 into sine 36, sine square 36 multiplied by cos 18 into cos 18, cos square 18. You can put the values of sine 36 and cos 18 directly, square it, multiply it and get the answer equal to 5 by 16. Please pause the video and do it now. Okay, after this question, the next one. Okay, so this part is over here. There is this exercise which I have already shared with all of you in the group. So I'll go to the next part, move to the next part, which is conditional trigonometric identities. Very important part, very interesting as well. This is a little lengthy part. So what we face over here is we have certain types of identities between sines and cosines, between cots and tans. When three angles are connected by a given relation, so there will be three angles which will be connected by given relation in all the cases, and we have to use this relation as a condition to solve these identities. So there is a certain algorithm which we will use here. First, we have to express the sum of two terms as a product by using CD formulae. We have to express the sum of first two terms as a product by using CD formulae. Sin C plus sin D, cos C plus cos D, if you remember the formulae. Then express the trigonometric ratios of sum of two angles occurring in this product into the trigonometric ratios of third angle from the given relation. That I will show you in the example. Then expand the third term in the terms of simplified factors by using sin 2 theta formula or cos 2 theta formula. Then take the common factor outside and express the trigonometric ratios of single angle occurring in the bracket into the trigonometric ratios of sum of two angles, and use AB formula to find the or prove the relation. So this must be really confusing for you, the algorithm which is shown here, but we will see with the help of an example that how we can make it easy. Okay, so the first question is here. So we have given that it has been given that a plus b plus c is pi. We have to prove that sin 2a plus sin 2b plus sin 2c is equal to 4 sin a sin b sin c. So we write LHS first, sin 2a plus sin 2b plus sin 2c. Out of these two, we take first two. Out of these three, we take first two, sin 2a plus sin 2b in a bracket. Now we use the formula of sin c plus sin d. What is sin c plus sin d? 2 sin c plus d by 2 cos c minus d by 2. Right? So we write 2 sin 2a plus 2b by 2 into cos 2a minus 2b by 2. And we keep sin 2c as it is over here. Now a plus b will be in the bracket, 2 will be taken out common and it will cut with the denominator. Same thing over here. So we get 2 sin a plus b into cos a minus b plus sin 2c will become 2 sin c cos c. Sin 2 theta is equal to 2 sin theta cos theta. Sin 2c is equal to 2 sin c cos c. So a plus b plus c is pi, which implies that a plus b is equal to pi minus c. So 2 sin pi minus c into cos a minus b plus 2 sin c cos c we get. So 2 sin c, pi minus c is c, right? Cos a minus b plus 2 sin c cos c. Out of these two terms, we take out 2 sin c. So we get cos a minus b plus cos c. Now what we do is we express this c in terms of a and b. Now a plus b plus c is pi. So c is equal to pi minus bracket a plus b. So 2 sin c in the bracket, outside the bracket, in the bracket we get cos of a minus b plus cos of pi minus a plus b. Now cos of pi minus a plus b is minus cos of a plus b, because in second quadrant cos is negative, right? Cos of a plus b, cos of pi minus a plus b is minus cos of a plus b. So we get cos of a minus b minus cos of a plus b inside the bracket. So cos c minus cos d, again we'll use the formula, and it says that 2 sin c plus d by 2 sin c minus d by 2. And if we simplify this, we get over here, we get 2a, which will cut with this 2, and we get just 2 sin a, and here we'll get 2b, which will cut with this 2 sin b. 2 sine A sine B. This 2 and this 2 gets multiplied, we get 4 sine A sine B sine C, which is your RHS. So you can pause the video, note it down, or you can solve it yourself after understanding. That will be better. Don't just copy it. Solve it. After watching this part, please solve it. Okay, so moving on to the next question. Okay, let's see what we have here. So here we have a plus b plus c is pi. Again the same thing. We have to prove that cos 2a plus cos 2b plus cos 2c is equal to minus 1 minus 4 cos a cos b cos c. So here also we write cos 2a plus cos 2b plus cos 2c, and we separate cos 2a plus cos 2b in a bracket. We let cos 2c as it is. Now we apply the formula or identity cos c plus d, cd formulae. Cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2 into cos 2c. So here we get 2 cos a plus b into cos a minus b into cos 2c. Now this cos 2c we write in the form of its double angle formula, that is cos 2 theta formula, that is 2 cos square theta minus 1 or 2 cos square c minus 1. Now here a plus b will be written in the terms of c, that is pi minus c, because we know that a plus b plus c is pi, so a plus b is pi minus c. Now cos pi minus c is minus cos c, so this minus sign will be taken ahead, minus 2 cos c into cos of a minus b plus 2 cos square c minus 1. So we take out minus 2 cos c outside and we get cos of a minus b minus cos c in the bracket and minus 1 outside. We can also do one thing, we can take this minus 1 ahead so that there is no confusion, but that we'll do in the second last step over here. First we'll express this c as in the terms of a and b, that is pi minus a plus b. So minus of cos of pi minus a plus b. So minus 2 cos c bracket cos of a minus b plus cos of a plus b, because cos of pi minus a plus b is minus of cos of a plus b, and minus minus becomes plus, so we get plus cos of a plus b here. Minus 1 is taken ahead as I told you earlier, and here we get, again we use formula of cos c plus cos d, cd formula, that is 2 cos c plus d by 2 cos c minus d by 2. On simplifying we get cos of 2a by 2, which is cos a, and here we get cos of minus 2b by 2, which is cos of minus b. Cos of minus theta is cos theta, so there is no issue. Now we can open the bracket. When we open the bracket, this 2 2s becomes 4, and we get minus 1 minus 4 cos a cos b cos c, which is equal to RHS. Very interesting to prove this. Okay. So what do we have? We have the last question over here. Very interesting. Please have your attention here. We have a plus b plus c is equal to pi. We have to prove that sin a plus sin b minus sin c is equal to 4 sin a by 2 sin b by 2 cos c by 2. So again we take sin a plus sin b together from LHS. We use c plus d formulae. Same thing how we did earlier. We express a plus b in terms of c, that is pi minus c. We separate this 2 in both the denominators. So we have pi by 2 minus c by 2, that is 90 minus theta. Sin 90 minus theta is cos theta. So we get 2 cos c by 2 into cos a minus b by 2 minus, here we use half angle formulae. So sin c is written as 2 sin c by 2 cos c by 2, because we want the answer in terms of half angle. So better we use half angle formulae. Now from both the terms we take out 2 cos c outside, so we get cos of a minus b minus sin c by 2. Now since you will see here that a plus b plus c is pi, we get c as pi minus a plus b. So here we replace c as pi minus a plus b, which is pi by 2 minus a plus b by 2. So sin 90 minus theta is cos theta. So we get 2 cos c by 2 bracket cos of a minus b by 2 minus cos of a plus b by 2. Now here we use sin c minus sin d formulae. So we get cos c minus cos d formula, which is 2 sin c plus d by 2 sin c minus d by 2. On simplifying, we get 2 cos c by 2 multiplied by 2 sin a by 2 into sin b by 2. And we open the bracket, we get 4 sin a by 2 sin b by 2 cos c by 2, which is your RHS. So that's your whole proof. Please solve it yourself, don't copy it. And that was, you can say, the final question of this part. So moving on to the next part without wasting any time, I'll be covering some more parts over here, maybe one more after this. So here in this part, what we have is the third type. Hey, wait. The second type was not covered by me. That was there in the same page. Let me show you. Yes, this is the second type which I was talking about. Identities involving square of sines. So here we have to change the square of sines into cosines of double angle by using this formula. Cos square theta is 1 plus cos 2 theta by 2 and sin square theta is 1 minus cos 2 theta by 2. Then it becomes same as type 1. So I'll show you how we'll solve this formula, how we'll solve this kind of questions. So suppose we have, these are also based on the conditional trigonometric identities, okay? So if we have a plus b plus c as 180 degree, we have to prove that sin square a plus sin square b plus sin square c is equal to 2 times 1 plus cos a cos b cos c. In place of sin square a, we can put 1 minus cos 2a by 2, sin square b will put 1 minus cos 2b by 2, and sin square c we have 1 minus cos 2c by 2. Then we split this denominator. See, 1 by 2, 1 by 2, 1 by 2, minus cos 2a by 2, minus cos 2b by 2, and minus cos 2c by 2. So we have 3 1 by 2s. It becomes 3 by 2. And we get minus cos 2a by 2, minus cos 2b by 2, and minus cos 2c by 2 separate. Then we take out 1 by 2, minus 1 by 2 out, and we get cos 2a plus cos 2b plus cos 2c inside the bracket, and we just derived its value, if you remember. So while you solve this question in the exam, you have to do the whole derivation and you have to convert this double angle into single angle, because see, in the RHS what we have to prove is not the double angle, it's the single angle. So how do we convert double angle into single angle? We directly use the identity. We don't directly use the identity, we use the relation which we have proved here. You remember this relation which we proved, this one. Cos 2a plus cos 2b plus cos 2c is minus 1 minus 4 cos a cos b cos c. We use this relation, but we, in the exam, if we get this question, we don't use the relation directly, we prove it. Here I have used it directly, if you see, right? Then we open the bracket, simplify, and we get the answer. So this minus 1 by 2 will be multiplied both the sides. And if we simplify, 3 by 2 plus 1 by 2 becomes 2, and this becomes plus 2 cos a cos b cos c. 2 is taken out common and we get our RHS. Right? Cool. So that's how you do this. So this part is little lengthier. So try to derive this part yourself, okay? Don't copy it as it is, like how I have done. Next question. Next question, we have a plus b plus c is pi, and we have to prove cos square a by 2 plus cos square b by 2 minus cos square c by 2 as 2 cos a by 2 cos b by 2 sin c by 2. Let's see how to do this. Okay, so we have in LHS cos square a by 2 plus cos square b by 2 minus cos square c by 2. So what we do is first we convert this cos square of cos or square of sine, anything we convert in terms of single angle, half angle. What I'm talking about, cos square a by 2 will be converted in terms of cos. Okay, cos square a by 2 will be converted in terms of cos. So in terms of cos square a by 2, we write 1 plus cos a by 2. And in terms of in place of cos square b by 2, we write 1 plus cos b by 2. And in place of minus cos square c by 2, we leave it as it is. Why we leave it as it is, I'll tell you little later. So we do the same thing over here. 1 by 2 plus cos a by 2 plus 1 by 2 plus cos b by 2 minus cos square c by 2. Now here 1 by 2 will be taken out common, and cos a by 2 plus cos b by 2, out of which we take 1 by 2 common, and in bracket we get cos a plus cos b. In place of this cos a plus cos b, we use the formula of cos c plus cos d. So we get 2 cos c plus d by 2, cos c minus d by 2, the same thing. And in place of minus cos square c by 2, we get minus bracket 1 minus sine square c by 2. This is important. Okay, so now if you see closely, in place of a plus b, I can write pi minus c. We can split this pi minus c into pi by 2 minus c by 2. Now cos of 90 minus theta is sine theta. Cos of a minus b by 2 will be as it is, and minus 1 plus sine square c by 2, this minus 1 will cut, if you see, with this plus 1, and we get sine square c by 2. Now sine c by 2 and sine square c by 2 will have sine c by 2 common, and inside will write cos of a minus b by 2 plus sine c by 2. Now in place of this c, we have pi minus a by 2. In place of this c, we have pi minus a by 2. Okay. So we have sine of pi by 2 minus a by 2, a plus b by 2. So sine 90 minus theta is cos theta. Sine 90 minus theta is cos theta. So cos of a plus b by 2. Now I had made a video up to this part only. So let me complete it. Okay. So we'll use the formula of cos c plus cos d. Now we have used the formula of cos c plus cos d earlier also. Let me just show you. See, cos c plus cos d, if you can see over here, that is 2 cos c plus d by 2 cos c minus d by 2. Okay, so here also 2 cos c plus d by 2. This is c, this is d. By 2 cos c minus d by 2. Okay, so here we get a minus b plus a plus b by 2, that is 2a by 2, which is nothing but a by 2. So 2 cos a by 2 into, here we get a minus b minus a minus b. So minus 2b by 2 or just minus b by 2, cos of minus b by 2. So sine c by 2 into 2 cos a by 2 into cos minus theta is cos theta, cos b by 2. Okay, so 2 comes ahead and we get 2 cos a by 2 cos b by 2 into sine c by 2, which is your RHS. If you remember, that's what you needed to prove. Okay, so this is how you prove this question. Very interesting. Conditional trigonometric identities. It has a pattern in which you can get lost, but if you get your hands on it properly, you can easily get through it. Yeah, so that was the second part, type 2 part of conditional trigonometric identities. Let's, without wasting any time, because we have this last part of conditional trigonometric identities, which also has maybe around 2 questions. So there is no point in, you can say, delaying and waiting for the next video. I'll just finish it in this video so you have some enough homework in your hands. Okay. So identities involving tangents or cotangents of angles. So what we have to do here is express the sum of 2 or 3 angles involved in the identity in terms of the third angle by using given relation. Then take tangents on both the sides. Here the algorithm is slightly different, but it is doable. Then you have to expand the LHS, then cross multiply and transpose. And in case of identity involves cotangents of angles, divide the product by tangents of all angles. So yes, as I told you that these algorithms might seem a little weird, but as we solve the questions, we'll find them they are very simple. Okay, so let's do it. Okay, so first question is in front of us. Let's solve this. If a plus b plus c is equal to 180, prove that cot b cot c plus cot c cot a plus cot a cot b is equal to 1. Okay, so we know that a plus b plus c is equal to 180 degree or pi. Can we say that a plus b is equal to 180 minus c? Now what we'll do is, since we have to prove everything in terms of cot, we'll take cot on both the sides. So cot of a plus b is equal to cot of 180 minus c. Cot of a plus b identity, we know it. Cot of a plus b is cot a cot b minus 1 upon cot a plus cot b is equal to cot of 180 minus c. Now see, in the second quadrant cot is negative, so we get minus cot c. Now if we cross multiply, what do we get? We get cot a cot b minus 1 is equal to minus cot c times cot a plus cot b. So cot a cot b minus 1 is equal to minus cot a cot c minus cot b cot c. Now if we take everything on one side, we get cot a cot b plus cot b cot c plus cot a cot c is equal to 1, right? And that's what we needed to prove, if you remember. So we used this given thing, that is relation, whether it's condition, you can say a plus b plus c is equal to 180 degree, and we solved it. So this is how you solve this kind of question. Okay. There is one more method which is discussed here in the solution, which I want to discuss with all of you. So see, a plus b plus c is equal to 180 degree. So a plus b is equal to 180 degree minus c. That is the first common step. But after this, we have taken tan on both the sides, which you can do, which is doable. So this third type, if you remember, I told you earlier only, this is the identities involving tans or cots of angles. So you can treat these questions separately, okay? So tan of a plus b is tan a plus tan b upon 1 minus tan a tan b is equal to minus of tan c. Then cross multiplying, you get tan a plus tan b is equal to minus tan c plus tan a tan b tan c. So tan a plus tan b plus tan c, tan a plus tan b plus tan c is equal to tan a tan b tan c. Now, if you divide this tan a tan b tan c on the other side, you get 1 upon tan a tan b tan c plus 1 upon tan c tan a plus 1 upon tan a tan b, and if you reciprocate, you get your answer. That's very easy. So this also can be one of the option for solving these kind of problems. Let's go to the next question. Finally, I pray to God that this video comes out right, and you know, it has been a long delay here. I'm not able to produce videos due to some technical issues, but finally with this video, I think I should get back the momentum. And not only you guys, but many other students are you know, waiting for my videos, and I'm not able to produce them so quickly, but I'm sure that things will be better now. Things are settled post Diwali. Okay, so here a plus b plus c is 180 degree. You have to prove that cot a by 2 plus cot b by 2 plus cot c by 2 is equal to cot a by 2, cot b by 2, cot c by 2. The sum of these is equal to the product of these. Wow, nice question. So a plus b plus c is equal to 180 degree. So can we say that a plus b plus c by 2 is equal to 180 by 2? That is a by 2 plus b by 2 plus c by 2 is equal to 90. So can we say that a by 2 plus b by 2 is equal to 90 minus c by 2? And further, everything is in terms of cot. So can we say that cot of a by 2 plus b by 2 is equal to cot of 90 minus c by 2? Yes. And can we apply the identity here of cot a plus b? That is cot a by 2 cot b by 2 minus 1 upon cot a by 2 plus cot b by 2 is equal to cot of 90 minus c by 2 tan of c by 2. Okay, so here what we'll do is we'll write cot of a by 2 into cot of b by 2 minus 1 the whole upon cot a by 2 plus cot b by 2 is equal to 1 upon cot c by 2. We can cross multiply and we get cot c by 2 bracket cot a by 2 into cot b by 2 minus 1 is equal to let me make some space, is equal to cot a by 2 plus cot b by 2. Let's multiply and simplify. So we get cot c by 2 into cot a by 2 into cot b by 2 minus cot c by 2 is equal to cot a by 2 into cot b by 2. Shift this cot c by 2 to the other side. So we get cot, sorry, this is plus cot A by 2 into cot B by 2 into cot C by 2 is equal to cot A by 2 plus cot B by 2 plus cot C by 2. So that's your required identity. Interesting, right? Let's go to the next part, next question. Acha, this example can also be solved as an Alater method of example 1, which I showed you, the tan method, not 10, tan. Okay, prove that tan of x minus y, why am I writing this? It's already given. Tan of x minus y plus tan of y minus z plus tan of z minus x is equal to tan of x minus y, tan of y minus z, tan of z minus x. So there is one method which would be easy to solve over here. We'll take x minus y as alpha, let y minus z as beta and z minus x as gamma. So alpha plus beta plus gamma becomes x minus y plus y minus z plus z minus x, which is 0. Alpha plus beta plus gamma is 0. So that means tan of alpha plus beta plus gamma is equal to tan of 0. And tan 0 is nothing but 0, remember that. And tan of alpha plus beta plus gamma has an identity. You know what is that? That is tan alpha plus tan beta plus tan gamma minus tan alpha, tan beta, tan gamma, the whole upon, I'm sorry for that, very ugly line. Yeah, the whole upon 1 minus tan alpha, tan beta minus tan beta, tan gamma minus tan gamma, tan alpha, and this is equal to 0 because tan 0 is 0. So what we do here, this denominator which you see, we shift it to the right hand side and it becomes 0. 0 into anything is 0. So here we go, we have the solution in one step. Therefore tan alpha plus tan beta plus tan gamma minus tan alpha, tan beta, tan gamma is equal to 0. So tan alpha plus tan beta plus tan gamma is equal to tan alpha, tan beta, tan gamma. And we just put the value of alpha, beta and gamma in this equation and we get our required solution. LHS is equal to RHS. How was that? Easy, right? So that was this part number, I don't know the part number now. Yes, this part. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th part. We are just done with the 10th part. So 10 parts. Now, very few small parts are remaining. Yeah, that was part 10. So very few parts are remaining now, which I'm going to cover in the next video very soon. And when you come in the live class next, now you know that we are just going to continue with the live class ahead. When all are back, we are going to focus on the chapter which is after trigonometry. Okay, so I'm going to see you in the next video very soon. Till then, take care of yourself. Bye bye.